So tonight's assignment is going to be on optimization. We did an activity in class that sort of introduced this section. And so what we want to do is we want to be able to apply calculus to solve optimization problems, and we need to make sure that we know how to select the appropriate model. We can build the appropriate function and domain, select and apply the appropriate optimization technique, and then verify that the extrema is actually absolute and not just local, and interpreting the solution in context. So the advice for mastering this section is going to be, well, we want to be able to state our goal in words, right? And sometimes that goal is just, we've said, you know, you may not always be able to write a sentence. Sometimes it's just identifying what you're looking for. Draw a picture, if we can, and label any values. Clearly state your variables and what they represent. And then identify any constraints on your variables. Write a function of one variable representing the quantity you want to maximize or minimize. State the domain of the function. And then find any critical numbers. So we want to find all the critical numbers within the domain. And then we need to verify that the critical number corresponds to an absolute min or max. And as always, when we complete problems like this, we want to end with a complete sentence explaining our answer in a sentence. So the first three steps of this process really sets up the physical framework for the calculus and the problem. So that's why we need you to make sure to get full credit for the setup that you're clearly stating everything that's asked. Often students will do the F and C parts, which are the function and the critical numbers, but then forget to do the domain and the optimization part of the process. So just make sure you understand that these can count for a third to half of the total points of the problem. The optimization step depends on your domain. So if the domain's closed, we use the closed interval method, which is where we make the table of values. If you have an open interval or something more complicated, then the first or second derivative test will find the relative extrema, and then we can use the property of our function to argue why they are absolute. So that could be using limits, that could be just knowing things we know about the function. And it says if your domain is an open interval and there's only one critical value, then the relative extrema of that critical value is automatically an absolute extremum. So what we mean by that is, let's say you have something like a quadratic. Well, a quadratic only has one turning point, and it either opens up or opens down. So the relative max or min that you find there has to be an absolute max or min. So we just need to make sure that we justify those things, because sometimes it feels a little strange to do overwork to prove an absolute max when it sometimes feels obvious. Make sure to revisit the C8 video if you need a well, it's not really in the video, but on the assignment sheet we have a table of important geometric formulas. And so don't always count on us giving those to you. You're expected to memorize and know the formulas that we've told you to be responsible for.